There are several forms of wired communication, but the most commonly used ones are the Modbus protocol. TCP, which is physically done with 4-pair Ethernet cables and switches. This allows us to share it with our local network, or not if what we want is to have an isolated network. Although there are some devices that incorporate it. RTU, which is physically with RS485 wiring, a single crossed pair with mesh. The connection does not allow star sections, but the different devices must be connected one after the other and the last one must have a 120 ohms resistor connected in parallel. It only allows 32 devices per loop, but we can create several loops. The RTU connection consists of a master or client and one or more slaves or servers. We have used a USB to RS486 converter for the client, which will be the device that runs Home Assistant. The servers can be commercial devices such as energy meters, solar inverters, or microcontroller boards such as Arduino, ESP32, ESP8266. That we have configured with an RS485 to TTL converter. In the video on this channel, Modbus RTU slave for ESP8266 ESP32 with Home Assistant control example, we show how to configure an ESP8266 as a server. There we communicated with it through another ESP8266 that we had configured with ESP Home as a Modbus client in such a way that our HO instance communicated with the client via Wi-Fi, and from there the RS485 communication to the other servers went out. In this video we will show how to configure HO to act as a Modbus client, configure the Modbus parameters, read registers from the device, and the most complicated thing is to send data to the servers. Although it is not necessary, it is interesting to create a table for each loop with all the data of our communication. At the top we will put the data of the protocol, name of the loop, connector, speed, parity. Below a column for each server with the name, slave number, and below a group for each instance with the type, name, ID, record, and the rest of the data depending on the type, switch, binary sensor. If we are in a virtual machine to direct the traffic to the converter, we must enable the USB/RS485 converter. For this we must have the converter connected to a USB port. Here is shown how to do it in VirtualBox. We will add the USB device to serial. To find out the name of the port where the converter is connected in Home Assistant, go to Settings, System, Hardware, All Hardware. Look for something similar to TTY USB copy device path. Now we are going to enter the code to configure the Modbus communication and also the sensors. In the comments of the video we have left a link to the code to communicate with the thermostat created in another video of the channel also referenced. To edit the configuration.yaml file we use the add-ons file editor. It can also be done with Visual Studio Code. We paste the code below the command_line. First we have the communication parameters that naturally must exactly match those of all the slaves. Next we will have the different sensors. In this example they all belong to the same slave. If there were more they would also be here. All these parameters are the ones we have prepared in the table. Scan interval is the number of seconds it takes between readings, 15 seconds by default. After saving we must restart Home Assistant for the changes to take effect. After restarting the communication it will start working and the sensors will already contain the received data. In order to send data to the slaves we will create two numeric helpers. We want to write to the maximum and minimum reference temperature registers of slave number 1. Settings, Helpers, Create Helper, Name ATTENCION, from -10 to 40 degrees Celsius. Step length 0.1 even though in the video it is 0.5. In the unit of measurement enter degrees Celsius. The second helper is the same but with the name ATTENCION. Also from ATTENCION. Here we correct the step length. To run the services of writing Modbus registers, we will create some automations that will be executed every time the value of the created helpers changes. In trigger, entity, state, we choose the maximum reference temperature helper and put from asterisk to asterisk. To avoid overloading Home Assistant, we will set 2 seconds during. In action, we choose other actions and perform action. In previous versions of Home Assistant it was called service. We choose Modbus write register. We put the address of the register to write. We activate the slave box and we put the slave number. In value we will paste the template that appears in the description of the video. It is to save a 32-bit signed floating point number in 2 16-bit registers. Finally we will put the name of the Modbus loop. We save and name the automation. We will do the same for minimum reference temperature. For this device to work in production, it would also be necessary for these automations to run when starting Home Assistant to keep the device synchronized. But the goal of this video is only to demonstrate how to implement Modbus communication, and it is already getting too long. We will also create some automations so that whenever the value of the binary sensor changes, the switch is set to this value. The first automation for off. We look for the binary sensor from any state to off. We save and name. And the second for on. We look for the binary sensor. From any state. To on. We also save a name. We create a visualization to control the thermostat and do the demonstration. We name it, choose an icon. We do it with the new section's visualization. We put 2 columns and save. In the first box we choose history graph. In hours we put 0.5 to do tests. Entities, Modbus temperature, Tmax, Tmin, and finally relay via Modbus. In the second box we choose the entities card. And we choose the entities, Modbus temperature, maximum temperature assistant and minimum temperature assistant. In subcard 1 we put the relay via Modbus entity activating the icon color based on its status. Finally on subcard 2 the button SW relay via Modbus. Done and the display is ready. Now we adjust the reference temperatures. We can check the adjustment in the graph. Since the temperature value is lower than the minimum temperature, the relay is activated and activates the switch. If we increase the temperature when the upper temperature is exceeded, both stop. Now the temperature is going down. We can test activating the switch and see that when reading Modbus, the binary sensor relay via Modbus is activated. We increase the minimum temperature to see how when the temperature drops, the relay starts up. And when it exceeds the maximum, it stops. We leave a link to the video Modbus RTU slave for ESP.